and security in AI. So as I'm sure many of you are aware, artificial intelligence has been increasing in popularity, both in research and industry. It's now being deployed in various safety critical fields such as healthcare and finance and engineering. Additionally, in light of sort of the changes produced by COVID, there's suddenly been this increase in sort of data that we suddenly have at our hands. And with this has come the kind of potential for using artificial intelligence to produce interventions that can more effectively deal with the panic. However, at the same time, there's been sort of increasing concerns about privacy violations, surveillance overreach, and general issues with a lack of sort of transparency. So I think it's pretty clear that the question of how we can achieve secure and trustworthy artificial intelligence is a critical one at this current juncture, and is only set to increase in importance as time proceeds. So hopefully in this panel we'll be able to discuss this question in a little bit more detail. We'll look at issues such as whether current trends in trustworthy artificial intelligence research accurately map the sort of realities of applying artificial intelligence in practice. We'll look at issues such as whether current research adequately balances values user privacy, whether these values have kind of changed in light of COVID. We'll look at what are the best ways of achieving explainability, achieving sort of artificial intelligence systems that can justify their decisions, explainability. And finally, we'll look at what exactly the role that regulations play in this story. Okay, so hopefully by the end of this panel, we should be able to get a sort of deeper understanding of the state of trustworthy AI research and also where it's going to be heading in the coming years. So to support this discussion, today we have a diverse panel of established researchers in various fields from CS, all with, I think, distinct and interesting perspectives on this problem. So I'd like to take a second now to ask each of the members of the panels to introduce themselves, and just to get the conversation started, to provide a sort of brief general statement, 1 or 2 minutes, about their general perspective on what you think is the best way of going about and achieving trustworthy artificial intelligence. So I think we'll go in alphabetical order, I guess, the order that's listed on the webpage. So starting with Professor Han.
Okay, so hi everyone. My name is Jun, and I am an assistant professor at SOC. And let me just provide a very quick introduction of my work and my group's work. We actually look into the intersection of sensing systems and security. So, we look into the applications of Internet of Things, cyber physical systems, mobile systems, vehicular systems, drones, etc. And so this topic of security or trustworthy AI is really of an interesting aspect also to my group, because a lot of our research actually utilizes some form of machine learning techniques. Whether that be utilizing that for security benefits or for risk assessments, or even providing some research exploration into novel attacks, because we want to explore attacks before they actually are launched in the real world. We want to sort of alert the security and sensing community and the computer science community of possible attacks. So yeah, so that's basically what I work on. And I guess going back to the moderator's question about the best way of achieving secure and trustworthy AI, well, it is a very difficult question. And of course, as with any security aspects, there is that golden question about the trade-off, right? It's a trade-off between security versus functionality. And so at least to me, it sounds like the recent advent and increase in machine learning techniques has been rather a little bit ad hoc in some sense, because given a huge availability of huge data sets, we were now starting to see very interesting and cool deep learning applications, etc. But it turns out that as we will discuss later, this explainability aspect of AI is that we are not able to explain why certain things happen. And so this is a great time for us, academics, to also team up with industry folks, because sometimes they have more resources in terms of data, etc., and to work together to actually really explore and find the best way of achieving such things. So yeah, with that, I'll pass it on to other colleagues. Karen, you're muted.
Yes, sir. I think the next person is Professor Roy Chaudhary. Abhi.
Hello, can you hear me?
The volume is slightly low.
Can you hear me now? Hello.
I can hear you. Yes.
Okay. How is it now? It's clear.
There's some crackling, but it's legible.
I see. Yeah. Okay, I will be brief. My name is AITrustworthy. I'm a faculty member in the School of Computing, Computer Science Department. So with respect to the perspectives on trustworthy AI, I think a lot of the interest comes from AI taking up a lot of the decision making in public facing endeavors. So for example, in granting of bank loans, or even in terms of conducting a remote surgery, and so on and so forth. Of course, the most well-known example of AI doing decision making is in the object detection in an autonomous vehicle, and so on. So I think a lot of the interest in trustworthy AI is driven from the utilitarian aspects of trustworthy AI, of AI taking up decision making, and hence it needs to be trustworthy. Now, from the academic perspective, it moves on a little bit from the utilitarian to the technical, which is that subsequently people talk of, well, what all we can do by using all our past technical backgrounds in trustworthy systems. So as a result, a lot of it moves towards verification. So Kiran, is it clear now? Is the voice clear now?
Yes, it is.
Okay. So I will continue. So from the academic standpoint, a lot of the effort that you see now, and probably what part of what we will discuss, is a lot on trying to make AI more trustworthy. As a result, there is a tendency to go towards the very, very formal angle and go towards verified AI and so on. And as a result, I see. So I think people are saying, just a minute, people are saying that they can't hear very well. So let me try to turn. Yeah. So how about now? Can you hear me more clearly now?
Yes.
Okay, yeah. So I think I just take off the AirPods. Yeah. So yeah. So maybe I just round up quickly. So a lot of the interest in the trustworthy AI comes from more the utilitarian standpoint, because AI is taking up a lot of the decision making, which is public facing, in terms of public facing e-services and so on. And then there's consequently there's impact on the academic community in terms of making use of a lot of the work in trustworthy systems, in particular techniques like verification, formal techniques, in making the AI components, like maybe a decision tree, a neural network, and so on, making them trustworthy. But to me, it's a little bit like what we have seen for the last 25 years on the verified software challenge. There have been a lot of, I would say, aborted attempts and missteps in terms of developing verified software. There have been efforts where people would say that, okay, there is no question that software cannot be verified. Here we have done it. There is this showcase example, but clearly that does not work. So I think people would have to get used to the fact that AI will be untrustworthy, and yet it will be used for important decision making. So how to move from the unit level trust to the system level trust? That means even though AI is untrustworthy, what kind of architectural differences we can make in terms of system building by using all sorts of primitives like the system design or use of isolation, or maybe use of maybe some amount of morphing where the system sort of heals itself. So it will be a combination of all of these techniques along with formal techniques. And this is more the conceptual angle, neither the technical angle and not the utilitarian or the practical angle. It is more the conceptual angle on which there is relatively less amount of work. And I would urge maybe just to put in a little bit of controversial comment so that people are encouraged to come in. So I would urge people to think, all of us to think along these lines and learn from all the mistakes in the past 25 years in the verified software initiative, where people try to build this absolutely formally verified software, which continued to remain a pipe dream. So instead of trying to build this verified AI, probably we need to start looking at other kinds of techniques apart from verification, which can be combined with it. Yeah, so that's my position. Thank you.
Perfect, thanks. I think the next is Professor Chokri.
Yeah, hello everyone. So first of all, I would like to thank all the program committee, all the students, graduate students from our school that I know how much time and effort they put into this with the great leadership of Yachi and Nitya. So this is going so far great. Thank you all. Going back to this, yeah, so I work on data privacy and trustworthy machine learning. And in terms of what is the right way to go about solving these problems, there are a few aspects of this that needs to be clearly understood. One is that as for any property in the computer science systems, we need to have a proper definition of what trust is, right? So for example, what privacy is, what fairness is, what robustness is, what is interpretability. And the computer science community has been working for decades on achieving these kind of definitions. So after many years of work, there's some definitions for privacy. There's a lot of struggle on defining what fairness is, and for robustness, still people are working on the definitions. There are many attacks and defenses, but there is no particular definition that people have agreed upon yet. So first question is like the definition. What is trust in machine learning? The second question is why these machine learning models might not be trustworthy. And to some extent, we know, and there is a lot of effort in that domain as well. If you are minimizing the empirical risk on your data, it's gonna minimize the empirical risk on your data, and nothing else. Is not going to mitigate the information leakage about your data, is not going to maximize its explainability, it's not going to maximize its robustness. So those are basically extra properties that we expect from it. Is not going to be fair. So understanding why it doesn't work and how this basically different, how this optimization problem might lead to lack of trust is the second part. And very briefly, then we need to design mechanisms with mathematical rigor to achieve those definitions. And these three together would help us to make getting closer to the goal of achieving trustworthy AI.
Okay, thanks. So I guess the final introduction is from Professor Zick.
Hello, everybody. Again, I want to join Reza in thanking everybody for putting this together. These things are extremely annoying to do, and so good job. And yeah, my name is Yair. I was at NUS until actually fairly recently, until June, so some of you might know me. And I'm joining UMass. I've already joined UMass, and I'm leaving to go there, hopefully by the end of this month, if Trump and COVID allow me. Anyway, so yeah, so I've been working and thinking a lot about the problems at the intersection of transparency and fairness and game theory and algorithms. Kind of that's basically what my research is about. And how do we make trustworthy machine learning? So I guess I want to touch on what Reza said and also what Abik said. And I completely agree that getting things perfect is not going to be easy because there are so many aspects to this problem, right? So we can talk about what trustworthiness means. So for some people, it means privacy. For some people, it means fair outcomes, right? So parity of outcomes between groups or just individual fairness or envy freeness or whatever it is. It could also mean security. It can also mean optimality, right? I mean, because at the end of the day, you can make a perfectly fair and private machine learning protocol, which is just going to output one, like basically like just the same output for everything. Like, and that would satisfy, I would bet, most definitions of fairness and privacy that you can imagine, right? But it's obviously pretty bad to do that because it's not accurate, right? So you want to, so it's a balancing act, right? And that's something that I think we should be very aware of as system designers and as people researching this problem, right? So that you need to make some trade-offs. Another thing here that I want to touch on very briefly is that we need to, my belief is that we need to come at this problem from a normative approach. And when I say a normative approach, what I mean is very simple. It's that you need to have some standards. Okay, we are not the first people to try to manage a big complicated system that has risks in it. Okay, so car manufacturers have been doing it for years and the medical community have been doing it for years. We're not the first people. And you need to come up with certain standards like ISO, right? So think, this is the way I want things to be done. I want it to satisfy these desiderata. What kind of mechanisms allow for it, right? What mechanisms satisfy it or approximately satisfy it? And do they fall within acceptable norms? And the last thing, and that's probably also touching a bit on what June said before, it's that it's important to maintain a contact with industry. And the reason for that is because a lot of people are not very aware of all of this stuff. They don't understand it. They don't understand what it means when you say fairness or when you say privacy. And there could be coders, right? There could be people who program this stuff. And that's absolutely fine. I mean, I didn't know anything about differential privacy until like Reza taught me 2 years ago, right? And that's absolutely fine, right? It's not like, it's not like we should look down on people who don't understand. The problem is that nowadays there are a lot of these implementations that come out of privacy suites and transparency suites that are rolled out by big players. I'm talking like IBM, Google, Microsoft, and so on. And the problem is that when you try to use them and you don't understand quite what they do, then you're basically trying to test whether a truck, say, has the same standards as a mini car. Right, and it could be basically sometimes it's very application dependent, and you can think that you're passing a test, but you're passing a test that was not meant at all for the system that you are testing. So I think we should all be very aware that we're not just creating another black box tool that kind of wraps around like trying to explain something black box. We're not helping. We're making things kind of worse. So yeah, so that's that.
Okay. Perfect. Thanks for the introductions. So just before we begin the panel in full, I'd just like to point out to the audience that there will be a Q&A session at the end of this, near the end of the panel. So if any questions pop up, feel free to leave them in the Zoom chat, and I will select a couple to relay when the QA comes around. Okay, perfect. So returning back to the discussion, I'd like to start by taking a more holistic view at the state of trustworthy AI research and security in AI research as a whole, and ask the panel, what do you feel are the best opportunities currently for achieving secure and trustworthy AI? In particular, are there any insights from sort of other fields? So as Professor Zick mentioned, car manufacturers have been, managing complex systems for a while. So are there any other insights from other fields, maybe CES research, that we are neglecting? Perfect. So.
Can you clarify what you mean by neglecting? Like
Are there any insights that we could bring in that that currently research isn't looking at? Yes, yeah. But that's just an extension. I guess the main question is, what are the best opportunities for achieving secure and trustworthy artificial intelligence? Yes. So, for example, what is the role of sort of hardware in this story? Or can we bring over insights from achieving trustworthy software over to achieving trustworthy artificial intelligence? So feel free to reply. So I don't think there should be any particular order. So if you have a response, feel free to say it.
Let me just jump in here and say, like, I think that the medical community is one that we should really look into, right? I mean, it's a fairly mature industry that has a lot of touching with kind of touches upon government entities and industry, and I think that there are a lot of parallels there. And there are very standardized ways of saying, okay, well, is this drug safe? Is this treatment okay? How do we test it? There are phases, right? I mean, now all of us are epidemiologists and medical experts because of COVID, right? So we now know there is phase 1, phase 2, phase 3. And I think that if you're going to talk about a high stakes application, then it's absolutely fine to do this kind of like slow and standardized testing and come up with these standards for AI and for machine learning, especially if you're going to talk about high stakes applications like finance and security and criminal justice and things like that. Like, just as a small insight, there was a few years ago, there was a talk by a professor, and he was talking about implementing basically to try to identify whether a crime in a certain neighborhood was done by a gang, right? So it was LA kind of gangs, and you want to try to predict. And the reason is because, if a crime is a gang crime, then it is important to know, because then you send certain types of police forces and you send out, maybe the sentencing will be different later because gang involvement is a criminal act in itself. So, and then you want to predict it. So what they did, they did exactly what you think they did, which is they fed in a bunch of data into a neural network in order to make the process much faster. And the first thought I had when I listened to the talk is, why do you want to make the process faster? Right? Why is this not a careful, deliberate, well thought out thing that we think very carefully before we accuse somebody of being a member of a gang? Right? I mean, sometimes it's kind of like this, you get on the bandwagon of doing everything with machine learning and you don't think for a second about why, kind of like, is this the right thing to do? And this is because there is a complete lack of responsibility and a complete lack of standards in the community. And that, I think, is in itself an evil.
Yeah, so I would like to echo a point. Is it okay to speak now, Kiran?
Yes, go ahead. It's ad hoc.
Okay, all right, yeah. So I would like to echo one point that was made by Yair in his earlier deposition in particular, that it would be quite bad because the AI module in particular is more like a black box. So it would be quite bad that in trying to give it trust, if we develop another black box approach to explain it or enhance trust to it. So, so there are a few issues in terms of enhancing trust that we could borrow. One, I already mentioned earlier, to distinguish between the system level trust and the unit level trust, and not to put too much focus on the unit level trust. Currently, if you see almost all of the research, or a lot of the research that is going on, is all about the unit level trust. People want to write academic papers on how to increase fairness of maybe a decision tree, or maybe how to increase certain kind of hyperproperty of a neural net, and so on. So in future, it's probably reasonable to expect that it's not that all of the programming will be completely automated and nicely be replaced by a neural net, but probably you will be working with a software and hardware systems where suddenly some modules of it get co-opted by a neural net or other kinds of AI models. So in that case, it's useful to distinguish between the system level trust and the unit level trust. And also this system level trust could be given by various techniques, one of which is explainability. So it would be good if at least the technique which gives explainability is not black box, that at least can be explained. So I think that's a very important point to keep track of. In terms of the research that we could do, so I would also like to clarify this earlier remark that I made with respect to the verified software initiative. Just because we move away from formal verification does not necessarily mean that we move away from formal thinking. That means the goal is still could be set formally. The goalpost could still be set very, very formally, while accepting that it would not be possible to give formal guarantees for one reason or another. So in terms of that very broad sort of formal thinking that we could bring in trustworthy AI, which currently does not exist in trustworthy software or trustworthy systems, we could draw an analogy between the first phase of program verification, where we just reason about pre and post conditions. It's really like terminating programs, and we have pre and post conditions, and nicely the program terminates. Then in the next step, we say that no, programs can be reactive systems, so therefore the event ordering is important, and therefore maybe we reason about temporal properties. And in the next step, when we look at AI, where really speaking, we are not just talking of one single trace, but collections of traces and their overall aggregate properties like privacy, fairness, robustness, then probably there is a need to formally think about and formally give support for hyperproperties. So this is a significant piece of research direction that I guess students here could take up. And in that process, one could develop some kind of formal thinking or formally inspired techniques, while accepting that it would never be possible to really exactly prove the hyperproperty in question. So the overall system needs to have some amount of balance for that. Yeah, so maybe I stopped there. I guess I would not want to take up too much time. Yeah.
Right. So maybe I can continue on this aspect about research topics and opportunities in the trustworthy AI. So as I mentioned earlier, I also look into research that is exploring new and novel attacks, right? And what I've started to really observe in our community is that a lot of novel attacks that utilizes machine learning techniques actually is quite surprising, and that's because for example, to human there are attacks that actually works that are seemingly not really possible. So in other words, there are sensing modalities, for example, that one would not feel that would pose any threats, but it actually turns out that it's actually really scary in some sense. So let me give you some examples. So recently in my group, and as well as other researchers in our community, have looked into ways to actually eavesdrop human speech from non-microphone sensors. Like, we're looking at, IMU data like accelerometers and gyroscopes on your phones. All of your smartphones have it, whether you realize it or not. And it turns out that these, sensing modality are actually susceptible to, or they're actually responsive to very minute vibrations. As I speak, my vocal cords actually vibrate minutely, and therefore it also vibrates very minutely, this sensing sensors on the phone. Well, it turns out that from human ears, when you actually play the recordings of these things, we cannot hear anything. I mean, we hear a bunch of noise, right? But if the attacker actually carefully utilizes machine learning techniques, one is able to actually discern if this is a digit 0 versus 2 versus 3, and such that the attacker could potentially actually capture all of your social security numbers or your credit card numbers or any other privacy sensitive information. So the way, and I'm going to get to the adversarial machine learning aspect of this trustworthy AI in a minute. But before that, I'd like to note that machine learning techniques, when used by attackers, for example, as a legitimate classification approach, it could still pose threats. And this is why I keep going back to this trade-off between security versus functionality, because how you utilize this tool could actually, when it lands in the attacker's hands, it could actually provide newer information for the attacker, which is actually kind of could cause detrimental consequences. And on a similar thought, my students and I have also looked into ways of actually extracting information, human speech information from robot vacuum cleaner, and utilizing the LiDAR sensor that is equipped on the robot vacuum cleaner in a similar way, right? LiDAR sensor is really a laser, spinning laser sensor, and so utilizing this laser sensor, you're able to actually extract certain information, certain speech information from this, right? So we can see that, of course, using that raw data, we cannot hear anything intelligible. We cannot get intelligibility. But if you actually carefully process the signal and then carefully utilize machine learning algorithms and feed in the right features, you're able to make a kind of a rather scary attack out of it. And so that's so what I actually mentioned to you is really utilizing machine learnings for extracting like side channel information. But on the other hand, many researchers have also looked into adversarial machine learning. So what this is instead of utilizing the classification or supervised learning in a legitimate approach, you would actually perturb the input, right, testing input, such that your model would get sort of quote unquote confused, and it would actually output a rather surprising result, right? So for example, let me give you an example. So if you are to use if you were to train a self-driving vision model, right? And you sort of give in a test input as a stop sign image, well, you're supposed to, your self-driving car is supposed to detect that as a stop sign, right? Or classify that as a stop sign. It turns out that some of the recent research, people have actually perturbed that input image of stop sign by actually, sticking some stickers on the stop sign itself, like physical perturbation, right? And what actually happened was that the classifier actually classified it as a 45 miles per hour sign, which is actually really scary and actually could lead to detrimental consequences, right? Because you're supposed to stop. So, I mean, this is just one example, but there are numerous examples of these adversarial machine learning. So, so I think that obviously provide, and in the research community, researchers have been trying to look into ways of defending such attacks, and how do we go about finding such defense is actually a non-trivial question, because it's always a cat and mouse game where I'm aware that there were a lot of papers that have been presented to propose for proposals for defense, but in the next n number of days or n number of weeks, other researchers have found ways to sort of beat that system to provide other types of adversarial machine learning. So this is a really fun and exciting times, but also at the same time kind of scary as well. So if you guys are, so if the students here are interested in looking into these aspects, I encourage you to look into these types of either the side channel attacks or adversarial machine learning.
So thanks for the.
So let me just go back to the main question that was asked. Basically, as a similar to the other disciplines in science, but in particular in computer science, what happens is that when there's a new set of problems, the whole scientific community gets at trying all the existing techniques and definitions that they had designed for other types of systems on the new system. So when we talk about fairness, privacy, robustness in machine learning, or interpretability, basically what has happened so far and is going to continue for years to come, people are going to just apply the existing techniques. They're going to apply the visualization techniques, and as they have been doing, they're applying game theory techniques, they're applying statistical methods, they're applying what we have learned about verification in softwares, they're applying database techniques and so on. Until, at some point, this gets pretty saturated and similar to the other, if you look at the history of other major problems in computer science, then it comes the moment, which has not arrived yet for trustworthy machine learning, where we go back and we try to design mechanisms or machine learning algorithms that are by design satisfying certain properties that we want, right? So instead of trying to fit these properties with the existing methods and algorithms, which may result in some unwanted trade-offs with other properties or with accuracy of the models and so on. So we go back and we try to design something fresh. Something which is very important here is that in the case of trustworthy machine learning, when you talk about machine learning, you're talking about some high dimensional data points in a space, and you want to find some boundaries between them for a particular task. Something which is very, it becomes very interesting at some point is that, these data points are actually some people, right? So these are their records. These records represent individuals, right? So then it's not only a border between two dots, it's rather the privacy of some individual, it's fairness, how we treat some individuals and so on, how much we can convince an individual that the decision was fair or not. So then this brings up so many new problems, right? So we are not just optimizing something, there's a metric and it's yeah, the metric is optimized. It becomes, this adds a new dimension to it. I want to go back to what Yair mentioned, that this trustworthy machine learning, in general, in computer science, we don't teach students to think in a responsible manner. Some people would do by default, they think about it, but it's not part of the education of thinking what would be the ethical consequences of using a method. So trustworthy machine learning and ethical computing are overlapping to a great extent. And so it becomes important, before you design a computation that, as Abig mentioned, is it's not only a neural network, it combines of so many different components. What would be the ethical consequences? And then trying to reason about the privacy, reasoning about the fairness and so on, aspects of the whole system, and whether that is something that we want or not. Usually we just rush into using techniques, and what happens is that we end up having a system that we don't want. So I think this is my take on how, and in the community, I think we are in the middle of understanding some of these problems, right? you're like 10 years from solving some of these big problems.
Okay, perfect. So I think in the interest of time, we should start moving. So moving away from this high-level perspective and sort of starting to delve into some of the more details, I'd like to touch upon one of the issues that was mentioned in a couple of the responses earlier, which is that of privacy. So ML requires, seems to require big data, and typically this is obtained at the sacrifice of user privacy. And so seemingly these two goals are at odds. So I'd like to ask the panel's opinion on this. Where do you think the balance should lie between sort of achieving accuracy, optimizing the accuracy of a model versus user privacy? Do we adequately value user privacy in current research? And sort of, sort of on a topical note, has this balance maybe shifted in light of COVID? Yes.
So let me start. Basically, when we talk about privacy in machine learning, there are two big problems. One is, are we talking about the implications of the privacy implications of using machine learning algorithms in society, right? For example, the implications of using very accurate face recognition algorithms, that you are in a crowd, they detect who each person is, okay? So there are some privacy implications of that if you use that and like install it everywhere, okay? That is like more related to the ethical aspects, right? Do you want to work on a problem that, could be used only in these situations for tracking people, right? That's an ethical choice, right? Do you want to work in a company that does that, and so on and so forth, okay? So there is this implications of using machine learning. And then the other aspect is the privacy or the information leakage of machine learning models when they are used on sensitive data. So if there is a hospital and then you train a machine learning model on it, then there are two issues. One is that who is training the model, right? Does that organization have the permission to have access to your data while training? Okay, there are a whole lot of techniques that allow you to train a machine learning model without looking at the data, okay? But then the more subtle issue is that after the model is trained, then the outcome, which is the model itself, or the predictions from the model, also memorize information about the data, and they can leak information, right? So these are this is the big picture. So I let other panelists also talk about this topic. If needed, I can come back to what are the techniques that could be used to defend privacy.
Touching back on the ethical part of it, I would say that, oh, sorry, June.
No, please go ahead first.
So, so touching back on the ethical part of it, I think that, and also relating it back to COVID, I think that one of the things that we need to be aware of is that let me say, maybe it's a little, maybe it's not entirely true, but I think that as a general statement, it's kind of is, privacy is not very important to people. It's not very important. And I think that COVID showed it kind of pretty nicely, right? I mean, we were all perfectly fine with having the Trace Together app installed on our phones and telling people exactly where we were at every single point, because there was some kind of a national or whatever a need to do so in order to maintain public health and so on. And the privacy considerations that went into that, I mean, it wasn't immediate, let's say, it wasn't on the forefront of discussion there, I would argue, right? And it's not like similar things were not, I mean, similar things were used in other places. I mean, I know for a fact that Israel does something very similar, and Canada now is rolling out another app. And I mean, of course, they all say, I mean, it's kind of, they offer us these assurances that these things are not going to be used in a bad way or whatever. But I mean, I think we can all be aware of the issues there. And I think that even on smaller scales, you can see this, right? I mean, you can say, well, you know, we can get better accuracy if we just forgo certain, you know, if we just let certain things slide, you know, like it's okay, you know, it won't be that type. We'll use certain features that might have risk, or we will assume more risk, you know, in terms of fairness issues and stuff like that. And then let me say this, I'm quite sure that if, for example, a large company like Google, they're perfectly able to roll out right now algorithms that are much more private and are much more fair than what they are at current. And possibly the reasons that they're not doing it is because, I mean, they're a company and they need to achieve certain predictive accuracy. And predictive accuracy is still, in my opinion, like an order of magnitude much more important than other considerations of like trustworthiness. And that's on the ethical side.
Oh, actually,
Yeah.
let me say something. So I disagree with what you said first. When people are given the choice of two systems that provide the same functionality, but one is privacy preserving, people by a large margin would select the one which is privacy preserving. So again, like about this tracing,
Equal, of course.
Again, like about this tracing applications, there is a way to construct it fully with privacy guarantees without any entity have access to the community. And there are surveys that people have done recently that majority of people would just choose the privacy preserving one. It depends on like how you would you know, present this, right? So if they don't have any other choice, and then you would come and just say, I'm not going to touch your data. You know, the history shows that they are going to use the data for other purposes, and the hackers are also not listening to. So if there is a concentration of data, they would attack. So people would just, prefer privacy preserving systems.
I'm not debating the fact, well, let me be a bit more precise here. I'm not debating the fact that if you ask a person on the street if they want to have their data protected, they would say yes. It doesn't mean that you will get less good Google search results. Yes, I don't care about the search results. Give me my privacy. I'm quite sure that this is true. I'm not debating that. What I am saying is that if you're talking about the major players, then they don't share that view. I don't think so. And this is also backed up by just historical kind of evidence of how they reacted to previous privacy leaks and issues with fairness and stuff like that. And the responses were pretty laconic and not like calling for any systemic change or anything like that. And on the level of governments, I mean, I'm not going to comment too much about the Singaporean Trace Together app because honestly, I don't understand how it works exactly. I can tell you for a fact that the Israeli version of it does have issues, like have serious issues that people, security experts have pointed out.
So
and it still goes on because there is
I actually think that this is a very interesting. I mean, right now we've been seeing some disagreements, and I think this is exactly what's really happening. And I think that's because there's not really a clear boundary where everyone would accept certain things or not. And this is because, in my mind, this is very subjective in the sense that certain societies would be willing to accept certain, things and willing to accept certain sacrifices for certain, applications, right? So, for example, COVID. If you ask me, I have no problem uploading my GPS information to the government, right? But certain people may feel that is too much, right? And so, if you think back, let's say just even a year ago. If a government agency mandated or at least suggested one to actually install such apps, that would have raised a huge, flag right there. It would have been like, headline news. Or, even some countries are, thinking about, asking some elderly to wear certain wearable devices. I think Singapore included, right? Or at least people are in talks with it. This would not have been acceptable, right? But at this point, I think this is most people would not really be opposed to this, right? At least in the countries that I can think of, because we accept the consequences, but there is the functionality that really benefits most people. So I think this is a very difficult problem to really answer at this point. But at the same time, as computer scientists, we should also be really aware and savvy about this problem. And I think that's why I think this panel discussion is really great, because many students are, at least I hope that this opportunity would enlighten many of the students to actually think in that direction as you're working on your own research. For example, if we think about face recognition that Reza has mentioned earlier, yes, there are many beneficial aspects to it, but then if face recognition gets further improved with correlations across different CCTV cameras, across different buildings and stuff, to enable contact tracing much easier, right? Then what we're going to see, the scary aspect of that would be that where's our location privacy going to be, right? Because now whenever I move, I will be tracked, right? To meter accuracy. So this is a very interesting aspect, and I think that we're living in a very interesting time where we are experiencing this COVID situation, which actually is something that we should also look into the ethical and the ethical aspects of this, and the lawful aspect of this as well. And how,
yeah. So maybe I will just very briefly address the question that Kiran asked, but from a slightly different angle. So related to this issue of big data and the data that is needed for training AI models, and whether this creates a violation of privacy. So one thing to notice is that there has always been kind of model-driven engineering in computer science, and the model building is never seen as one shot, but an iterative process. Somehow in this process of the AI model building, currently it is being seen as a one-shot process, that you have big data, you train, and you produce an AI model. Clearly, there are ways of going around it. So you could probably have a discrete model, which is not a good model, but a poor one. And you could try to take the deviation of that discrete model from the actual measurement and train the AI model on this deviation. That itself becomes more privacy preserving, because you are not really feeding the actual data for the purpose of creating the AI model. And then you could probably better your discrete model, as well as try to better the AI model next time around by putting in an iterative process. This allows for an iterative model building, as well as is more privacy preserving. So clearly there are many ways around it that one can benefit from the many years or decades of model-driven engineering that already exists in computer science. So that would be my very brief answer. Yeah.
So one thing, actually, going back to this, the trade-off between privacy and the functionality, right? Is that basically, especially in the context of machine learning model, what we want from a model is to generalize to the data beyond its training set, right?
Okay.
And for privacy, what we want is that the model should not be dependent too much on its training data, so that correlation could be exploited by an attacker to reconstruct information about the training data. So the relation between, there's a direct relation between generalizability, which is a good property that we want from machine learning models, and privacy, right? So in that sense, compared to some other computations that we want to do on large data sets, in the context of machine learning, these two are hand in hand. Like it is possible to design machine learning algorithms that are privacy preserving and at the same time are accurate, right? So it can achieve functionality and privacy at the same time.
Yeah, and in fact, the exact data that is kind of so private need not be used for the purpose of the training. So you could kind of create a reference. I'm not just talking of anonymization. It could be the deviation of that data with respect to another discrete model that you have created. That simply makes it a bit more private. So there are ways around it. It need not be that exactly a lot of data has to be created, and then you will create one shot, a big black box model which nobody can understand. So this is really a the way currently the models are being constructed is really a very primitive way of constructing models. And this is not the way usually models are constructed in computer science. So there would be, I'm sure there would be improvements along these lines, yeah.
Just to tie back to that, in order to get those robust models, then you need to have a really good data set, right? So this also arose in discussions that Reza and I had privately, but to tie back to it, to create robust models that satisfy these nice properties, then you have to have good data. And if you don't have good data set, or in some regions, some regions of the data set are sparsely represented, and you do certain tricks to still make it robust or to make it private and so on, then that usually creates trade-offs in other aspects of trustworthiness, like again, like explainability or fairness and so on, right? So and that's a problem. Like just one small example of how that problem arises is that, okay, so there is a lot of studies that show that certain facial recognition algorithms are biased against ethnic minorities and female, right? And in particular against females who are of an ethnic minority, okay? And one way to overcome this is by somehow amplifying the data points, right? That are, so if you have a facial recognition task, then amplify the points that are female and black, let's say. But the problem is that when you're doing that, then that immediately creates a privacy risk for particularly that group that you are trying to help. So it is, you get into this terrible problem of, again, which poison do you want to drink? And that is I think, an issue that we need to, again, be aware of.
Yeah, I agree, but probably there isn't a nice solution for it right now. But one way around it might be to create synthetic data to augment the data set so that the model is more robust, and at the same time, it's not compromising privacy so much. But to do that data augmentation very systematically, that's synthetic.
But if you do data augmentation, which is something that has been going on, there is a really interesting ongoing debate in the transparency community about data augmentation, because a lot of times when you want to create a model explanation, you need to use data.
Right.
Okay? And you use so then the question is, how do you do it? How do you generate this data? And one way is, as you exactly say, is to use synthetic data, basically to create some fake data points and explain through them. The problem is with that is that it creates a whole lot of problems. First of all, your explanations can become very bad. They just become nonsensical. Another problem is that you're not able to identify the effects, that you're not identifying correct effects. And what's worse, an adversary can then come, and if they know that you're using this synthetic data, they can create models that are absolutely terribly discriminatory, but they're masking it because they're kind of like exploiting the fake data. Basically, you're sampling outside the data manifold, and because of that, you can mask a lot of adversarial behavior. So
no, I think we are on the same. I think we are on the same page here.
Yeah,
that
for sure.
Essentially, overfitting or generalization is clearly kind of right. That's a major challenge. Yeah.
I'm just pointing out the fact that, like, it's one of those problems. It's like a whack-a-mole. You push one and then another one comes up, and it's not. It never goes. The problem it never goes away. It just goes to another place, and you just need to decide where is the place that you want it. That's all.
Okay, so I guess in the interest of time, just so briefly, I guess we should touch on, we started discussing slightly other aspects of trustworthy artificial intelligence, such as explainability. So I guess, could I pose the following question to the panel, which is, what do you think is the relationship between explainability and trustworthy AI? So this was slightly discussed in a couple of the previous responses. In the interests of sort of the time remaining, and so we have enough time to go over the questions, try and keep the discussion to around sort of 2 minutes per speaker. Yes. So yeah, is explainability? What is the relationship between explainability and trustworthy AI? And is explainability? As it was mentioned, is explainability really important in achieving trust? Are there sort of other ways? Can we look at a sort of more holistic sort of level trust instead? Do we really need explainability?
I will say 2 words about it. I will try to keep it to 30 seconds, and then there's the premise. So, very important. The main question is a question of what do you want to do with it? And this is another discussion that's been going on, which is about recalls. Okay, so how do you explain? So let's say I tell you, Reza, the bank rejected your loan, like the AI algorithm said no. Okay, and then one option is to tell him, okay, Reza, it was because of this and this and this feature. Another option is to tell him something like, this is what you need to do in order to become to get the loan. To give you what's called actionable recalls. And this is a much more challenging thing to do and to reason about than just generative explanation.
Right, and I completely agree with Yair. So just let me just keep this short as well. So like I mentioned earlier, there's problems with adversarial machine learning. These are partly because of the fact that the models are kind of like, not explainable, like more like a black box, right? So there have been, and of course, if we are able to understand more of these models, then we may be hopeful that we can eliminate at least some of these attacks, right? So, for example, and we're seeing some promises, right, in research communities. So I'm aware that some research actually looked into determining, additional insights, like what Yair was saying, like which features contribute to what, or even like, for example, in computer vision, classifying, cat versus dog, for example, to pixel level. People have been, producing like heat maps, right? Such that we would know that which of the pixels contributed to classifying a cat versus a dog, and correctly or incorrectly. So in some sense, additional insights or contextual information from this could potentially help the explainability, which is really important, which could naturally lead to the original question of the relationship between explainability and trustworthy AI.
So if I want to add something to this, is that explainability becomes important exactly at the point that we realize those dot points are basically people, right? And the way that is presented so far is that you want to explain to the person who's using the machine learning model, but more or less what the main reason why you need explainability is to correct the decision making of a system that is based on a machine learning model, right? So if the decision made by the model does not make any sense, right, or it's not fair based on the rule that you discover, then you would need to correct it, okay? So it's more adding, call it like transparency, right? So you want to add more transparency to the decision-making process in order to fix it. In that sense, it becomes very important, and a system that provides explainability and is more transparent would create more trust. That's basically, I think, the main reason it's needed.
Yeah, so I'll, in the interest of time, maybe I'll keep it extremely brief. So I think, like the example that June gave, so for unit level trust, explainability is important. If you want to trust a single machine learning model, explainability is important. For system level trust, explainability may or may not be important. because maybe one of the components is a machine learning model. It's not entirely explainable or trustworthy, but the other components can compensate for it somehow. So then explainability may or may not be important. I could elaborate on it more. Explainability is more along the lines of, in the software context, what we call as program understanding or program debugging, where you try to find out exactly what is wrong with the program. But as people have figured out in the field of software, that it's not necessarily needed to know exactly what is wrong with the program. As long as all of the components taken together can work holistically so that the error is not manifested. So right now, for example, I am giving this talk. You probably do not necessarily need to understand what all is wrong in my health, exactly what is wrong in my health. As long as I can explain about explainability, give a decent explanation, you are okay with it. So that means all of my components in the body taken together are working good enough that it is serving your purpose. Exactly what is wrong with my health, whether there is a small lesion in my hand, which is one component of my body, may or may not be important, as long as my trustworthiness is concerned as a person. But if you are concerned about the trustworthiness of my hand, where maybe there is a lesion, then that's important. So I think I will put it that analogy and here. Yeah.
Perfect. So I guess I'd like to, just to make sure I'd like to sort of relay one of the questions from the chat, starting the Q&A session slightly late. So I think Sal Dawal Pei asked to the panel in general, does a person's privacy become less important if by giving up it benefits greater society? Taking Professor Jun's example of COVID, if we have more data, it could aid in tracing and vice versa, but mandating it would be a breach of an individual's right. So the question itself was, does a person's privacy become less important if by giving up it benefits greater society?
So I guess maybe I could start. I guess that's actually a difficult problem to answer directly. And to be honest, I don't have a clear answer for that. What I can say though is that as a computer scientist, as I mentioned earlier, we should be aware of this problem. Being aware of the problem is actually going to go, very far into, trying to help the society. But at the same time, trying to protect individual rights. And of course, this is quite an ambiguous answer, but I think that as long as we, are trained and we train you to, think about certain privacy in mind, I think that would go a long way as you become a seasoned researcher and engineers.
Perhaps I'm not sure that we are the right people to ask this, right? I mean, this is exactly. But, it's a good question, but this is a good question for asking about maybe it's a question that to be asked by the legal community, or maybe we're not the only ones that need to answer it. It's more precise. We should have answers. So the legal community, the society, humanities, and things like that. That's definitely have asked variants of the questions that you're asking. And I mean, one just example that just pops to my mind is the one. There was the Boston Marathon bomber. So this was this guy who decided that that they wanted to bomb the Boston Marathon, and they killed a bunch of people. And I believe it was the CIA. They wanted to hack into his phone. They wanted access to his phone, and then they asked Apple to give access. This guy is a terrorist. They give us access to his phone, and Apple refused. At the end of the day, I'm not sure entirely about the full facts of this case, but that's my understanding of it. And I don't know, there is a whole spectrum of opinions here, and some people, it really depends on what you believe, what country you're from, what kind of tenets you have, and I don't think it's an intrinsically CS question.
Okay. So I think that's about all the time we have. So I'd like to.
I think because this is an important one. I was waiting whether
sorry.
Abik wants to say something or not.
No, I don't want to say anything.
Yeah. So there is a there is a technical aspect and there's a non-technical aspect to this, right? So the non-technical aspect is that, so life is about balancing different values, right? And if you study the philosophy of ethics, there is no single solution. But when it gets to a technical problem, then it becomes important for us to define in that sentence, in that question, what you mean by privacy and what you mean by benefits for the society. Asking that question from a computer scientist, I want to quantify that, right? If it's basically defined in the context of tracing people for identifying the encounters, right? Then I can define the functionality that you want from that system. I can define the privacy risks and the privacy requirements for that system, and I can construct the system as we have done and others have done that it is possible to achieve that benefit and the privacy, right? So that's, I think, as a job of a computer scientist, we should not always wait for the problem to be formulated for us, right? So you want to go and identify what are the consequences of using a system and what are the objectives, and then design a system that achieves all these things, right? In the long term, it's very beneficial for a society that is built upon systems that are privacy preserving. It brings up the trust level in that society or in an organization. So in the long run, you would gain more, right? Even if you don't sacrifice for the functionality. I think these are the things that are very interesting. It's a good question, and we need to think about them. We need to discuss more about these things.
I completely agree, and I would like to add that if you talk to people, like as researchers, you talk to lawyers, you talk to moral philosophers, I think it would benefit you immensely, because like there is the last research week, there was a Kobe Nissim who came, and he said he works with people, legislators, and they asked very simple questions like, I mean, what kind of privacy definition, what kind of differential privacy or whatever privacy definition you like, complies with privacy law, right? And I think that's an absolutely amazing question to ask, right? And it leads to interesting ideas of how you define it. And I mean, I see it from the fairness side, right? So we talk to people at the public housing, at the Singapore public housing, and it informs us on how to design fair algorithms for allocating indivisible goods, right? There is a massive benefit to just doing that interaction. And yeah.
Okay. So I guess we have a couple of we have one more question that was posted in the chat. So a question sort of addressed to Professor Zik. In the area of fair, trustworthy, transparent machine learning, what do you think of bringing people in the loop, which I think is important but less explored from CS? For example, in fairness, it is a fact that what is fairness is subjective and should adapt to the changes in people's beliefs. It seems some people are marginalized in machine learning. So the question itself is, in the area of fair, trustworthy, transparent machine learning, what do you think about bringing people in the loop who are sort of less experienced in CS? So I guess bringing in.
Right. So I'm sorry, the person laughing in the background is not me, that's my son. But sorry, it wasn't, I mean, the question is not funny. The short answer is yes, of course. Yes, we should kind of get people involved, whoever wants to be involved. I mean, I would like to think that the fairness, accountability, transparency community is a fairly open and community. I mean, yeah, if you have any good ideas and you want to discuss them, then please, get in touch. We will talk about them. I am aware of a lot of efforts, right, of people kind of more concretely, right, apart from this like abstract answer. There are very concrete people, like, that you talk about, should we bring people in who are not CS people to talk about fairness, accountability? So the answer is yes, and it's already happening, right? So you have people who actively talk with Sandra Wachter and Sorel Friedler, Aaron Roth, myself, Reza, people who talk with legal scholars, with people in ethics, people in economics, and you know, it's ongoing. It's more difficult. It is sometimes less rewarding because you would be amazed at the amount of effort that goes just into settling on a common language between two disciplines. But at the end of it, it is, I think, a very good discussion to have. So yes, so the answer is unequivocally yes, it should happen, and it does happen.
So I guess if there are no further comments, there was one other question in the chat, which is I guess from Sam. So he says, how does an aspiring AI, artificial intelligence pen tester balance their expertise in both artificial intelligence and security? So Sam is an undergrad InfoSec student, and being well versed in both artificial intelligence and security sounds very difficult. How in depth should he go in both fields to be effective?
Yeah, I think for going into any area, it would be good to think of an entry point. So rather than like, okay, this involves both artificial intelligence and security. So first I learn all about artificial intelligence, and then I learn all about security, and now I'm ready to work on both of these areas. I think in either for working cutting edge in the industry or in working particularly in research in an area, it's very important to think of your own angle and your own entry point. Even now, whenever I am trying to do research in a new topic or a new area, the first thing that bothers me is what is my entry point and what is my angle. And I feel you should, well, this, of course, there might be many answers to your question, but I feel you should think of the question in this light, like what is your angle, what is it that interests you, and what is it that you can contribute, rather than trying to learn like an entire stack of things for AI, an entire stack of things for security. It really doesn't work that way. At least that would be my take.
Yeah, I think that's a great point. And one other thing is that it depends, you know, Abhi talked about the entry point, but then also it matters what you want to do, like what is the end goal, right? So you want to get a job in a particular type of companies, then you need to you know, work on certain skills. You care about privacy, and like that is, you think that like everybody needs to care about that. You want to build a society, a set of systems and tools that preserve users' privacy, then there is another entry point for that, right? So that is, I think, very important. So I encourage everyone, you know, all the researchers, undergraduate students who want to go to the, you know, industry or research, you know, you are spending the best years of your time. So better to think about what you want to be in 10 years. And then definitely, you know, you can find the right entry point for you, you know, getting to your, achieving your goal.
Okay, there was another question on the chat, which was from Will. So what do you think of federated learning, which trains a model on devices that have data instead of centralizing data in a single point, in the big data picture, in the big picture of privacy / trustworthy artificial intelligence?
So, you know, the idea of training a model in a distributed way is a very old idea. There are a lot of like interesting algorithms in this domain, but we started this field of federated learning back in 2015 on a paper called Privacy Preserving Deep Learning. And the idea was this: if we have different parties that have the data is put in different, you know, owned by different organizations, but they are interested in training a single model jointly on all the data without sharing the data with each other, right? Then how can they train a model such that it's it satisfies the privacy requirements of these data owners, right? Different parties. So you can consider, different mobile phones. They want to train a model jointly without the data leaving their mobile phones, or the different hospitals want to train a model jointly without the data leaving their data centers, right? So basically so you can and this is what we suggested, and today Google, Apple, and many other big players, so many startup companies are using this idea. It works. It's based on some distributed algorithm for machine learning. However, the catch here is that not sharing the data is not enough to preserve data privacy, right? So the computations that you do on the data, and you share with others, or you share with a centralized party to aggregate and send back to the parties, would still leak a lot of information about their internal data, right? So federated learning by itself is not a privacy mechanism, although it's not been advertised this way, because the industry got interested into this, and they put federated learning alongside some other privacy mechanisms as a way to protect privacy. So it's not protecting privacy by itself, but it is possible to actually design mechanisms, although they are difficult, to mitigate the privacy risk of this information leakage, this information sharing, which is usually the model parameters, yeah. So that's the catch. So if you look at like the videos that you see from, I don't know, Google and other, what they say is that we do federated learning, your data remains where it is, hence your privacy. Actually, the number of dimensions of the information, which is the model parameters that is shared in federated learning, is larger than the size of the data set that is stored in each of the by each of the participants. So it can leak a lot of information about their data. And it's an iterative process. So eventually the adversary or the observer can reconstruct a lot of information about the data, unless that is shared in a privacy preserving manner.
So maybe maybe I will not get a chance. So before we wrap up, I would like to thank Kiran for running this panel so well and so efficiently. It's really a very good set of discussions that he has coordinated. And I guess the students also, as they go through their PhD career, they will realize how valuable this experience and exposure is. So I would just like to take this opportunity, if I may, to thank Kiran for doing such a wonderful job.
Perfect, thanks. I guess following that, I think it's a good time to start wrapping up. So if any panel members want to make any sort of closing statements, maybe any points that they want to sort of emphasize, to take away for the audience, feel free to sort of speak now.
Yeah, so continuing what Bik was saying, great job. I encourage, this is the opportunity for all of us to learn how to get engaged into some interesting discussions. So, there will be one more panel. There will be events in the future. Get involved and basically practice how to discuss some important topics in research. Thanks, Kiran. Thanks, everyone, for attending this.
And thanks to Reza for organizing, being the spiritual leader of the research week. Right.
Yep.
Well, the students did the job, right? So I was like, yeah.
So that's why I said you are the spiritual leader.
Is everybody's spiritual leader.
Thanks, Reza and Kiran. And also, I'd like to encourage all the students, especially also the undergrad students attending this talk, to also be actively taking part in attending, the rest of the CS week. We have very interesting research, talks lined up for you in our school. So please make sure to attend all, or if not most, of the talks. Okay.
Yeah. It was really fun, and I hope to see you again in person, everybody. Yeah, so I miss everybody already.
You are in Hawaii, right? So the background says.
Yes, exactly. On the beach. I'm in an empty apartment. Anyway, okay, guys, I will drop off as well at this point. Thank you.
Okay. Yeah. Thanks again to Reza and Kiran and the program chairs. Yeah.
Thank you all.
Perfect. So I guess I think that brings us to a stop. I'd like to thank all the panelists for the very insightful discussion into into trustworthy artificial intelligence. I'm sure I gained a lot from that, and I'm sure a lot of the audience did as well. So thank you, everyone. I think this is a good place to call the end of this panel. Okay.